Algebra 1, section 11.1. This lesson is going to be a little bit different in that I don't really have much to say to you about it. It's different from the worksheets, obviously, because we're back to doing book assignments. But basically what I'm going to do here is just power through a bunch of examples. You all had geometry, so a lot of this is going to be a review of the times in geometry when we were simplifying radicals. If you need me to slow down, you always have the pause button. Otherwise, I'm going to go really fast here. Okay, so I may skip a few of these. We may end up doing all 48 of these problems, but it's going to go fast. All right. So number one, you should remember that there is this idea of simplifying a radical, simplest radical form. To say the square root of 32, some math nerd one time many centuries ago decided that that's just not good enough because you can divide a perfect square out of there. Now, when we did this the first time, what I would have done would have been to generate a list for you. And I would have said 4, 9, 16. This is 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, 11 squared, 12 squared, and that's probably good. You probably wouldn't go above 144, which is 12 squared. All right. Now, I'll never give a class this to choose from, you know that, but you could always generate that list by just 2 squared, 3 squared, 4 squared. I have students who do that, and they'll just write that down to reference it. Okay. So what off of this list does divide into 32? And the quick answer is 4. But look deeper. Is there something bigger than that? You see, because you could divide out 4, and that would leave you with the square root of 4 times the square root of 8, which is actually 2 times the square root of 8. And we shorten that and we just say 2 root 8. But the square root of 8 is not in simplest radical form. So then you'd have to divide out another number. So if you can see that ahead of time, what you really should do is divide out a 16. So this would be root 16, root 2, and then you want to square root that. The whole reason to do this is because you took out a perfect square so that you can take the square root of it. And our answer is 4 times the square root of 2, or you should just say 4 root 2. Okay? Now, another thing that we learned about radicals is that you can multiply them. You can multiply the 22 and the 8, and that would be 176, square root of 176. And then we should look to do the same thing. Can you take out a certain number out of 176? And use your calculator if you need to. That number is 16, root 16, and that would leave you with 11. So our answer is actually 4 root 11. Okay, here it would be 49, leaving you with 3, so 7 root 3 is your answer. Now, just as it works for multiplication, that when you multiply things that are under radicals, that you can put them under 1 as a product, it's the same thing for division. And you have 17 being divided by 144. You can't square root 17, but you can square root 144. This is like saying root 17 over root 144. The square root of 144 is 12. So it's perfectly fine to say root 17 over 12. Okay? Now you might think that there's a problem because of a irrational denominator. Not the case, right? 12 is a rational number. It's okay to have an irrational numerator. The square root of 17 is irrational, but 12 is rational. It's perfectly fine to say square root of 17 over 12. Do be careful to not write it like this. Don't go root 17 over 12. That's wrong. The 12 is independent of the square root symbol. Okay? Now, continuing with other concepts that you did learn once upon a time is when you have a denominator like this, check it on your calculator if you like, the square root of 6 is irrational, and we can't have that. So what we do is this process of rationalizing the denominator by multiplying by the denominator over itself. And that would then be 2 root 6 over 6. You see, when we multiply by the denominator over itself, and then you multiply that, root 6 times root 6, you get just 6. There's your rational denominator. And then your numerator, it just kind of has to come along for the ride, 2 root 6. One thing you can do, though, and I'm trying to make this so you can see where my answer is. I'm trying to put them on the answer blank. One thing you can do is reduce the fraction to 6. That would be 1/3. So your best answer here is root 6 over 3. Okay? Next, you could take out 16 here. Root 16, root 5 would be 4 root 5. Here, you could take out a 9. Root 9, root 3 would be 3 root 3. Here, if you rationalize the denominator again, you'll get 8 root 7 over 7. And that does not reduce, so that is your answer, 8 root 7 over 7. I told you I was going fast. I am going to come back to problems like this. We'll do those at the end. 10. You can take out 100. Root 100, root 2 is 10 root 2. Square root the 100, you get 10. Root 2 needs to stay root 2. Next, this would be, well, 6 times 50 is 90, so the square root of 90. Can you take a perfect square out of 90? You can, and it would be 9. So root 9, root 10 is 3 root 10. Something that I often see, a little sidebar here, is I'll get somebody who writes that one and they'll go root 9, root 10, okay? And then they square root it and they end up with like root 3, root 10. No, you see, when you square root of the 9, it became 3. There's no reason to have that square root anymore. It's just 3 root 10. That's the answer we got here. Next, you could take out just a 4 here. You might think there's some bigger numbers that come out of 120, but actually 4 is the biggest number. So the square root of 4 is 2, and then what's left is the square root of 30. I'm going to come back to this kind of problem again. We'll do those at the end. Square root of 250. You can take out a 25. That would be 5 root 10. Here's an interesting one. You might think, oh, rationalize the denominator. If you do that, fine, you better grab your calculator because you're going to have to multiply 65 by 13 in the numerator here, and then you'll get a denominator of 13, and then you'll have quite a fraction to reduce. But actually, again, just as we did up here where we multiplied 22 and 8 and put it under one radical, that's a rule. That's a property in math. Same thing for division. You can divide 65 by 13, which would be 5. The answer here is just the square root of 5. Square root of 65 over square root of 13 is the same thing as saying the square root of 65 over 13, and then just divide what's underneath the radical. You'll get the square root of 5. Coming back to number 16 later, look at 17. Now you have a multiplier. That's 3 multiplied by the square root of 24. Let's go ahead and simplify the square root of 24, and then whatever gets taken out can be multiplied by the 3. So that number that gets taken out is 4. So this is really like saying 3 root 4 root 6. Root 4 is 2. 3 times 2 is 6. Here you have 6 root 6. By the way, if you have use of a calculator, and we did employ, if you had been here, we might have employed some no calculator stuff to this. But if you have the use of a calculator, feel free to check. 3 root 24, see what the decimal is. 6 root 6, you should get the exact same decimal. Okay. Here you could take out a 16. Root 16 root 10 would be 4 root 10. Here you could rationalize the denominator by multiplying by root 3 over root 3. That would be 6 root 3 over 3. And then 6/3 reduces to 2. This is 2 root 3. Here you can divide just like you did this one up here. 180 divided by 9 is 20. So this is like saying root 20. Don't stop there because you can simplify that by taking out a 4. Root 4 root 5 would be 2 root 5. Here, very similar to one or more that are above. So that's just going to be 12. If you multiply 18 and 8, you'll get 144. The square root of 144 is 12. Here, you're going to get, this is very much like number 4. And you're going to get the square root of 17 in the numerator, and then you can go ahead and square root 64 in the denominator. That is 8. Root 17 all over 8. Here you can take out 25. This would be 5 root 2. I told you I was going to go fast. Here you can take out root 16. So root 16 root 3 is 4 root 3. Here you can take out a 4. This would be 2 root 5. Next would be 2 root 2. We're going to come back to that. Using a different color so I don't forget which ones I told you I'd come back to. Here, very similar to one we just did up above. So that's going to be root 13 over 9. Root 13 all over 9 because you can square root the 81. 48 divided by 8 is 6. This is just the square root of 6. 120 divided by 10 is 12. This is the square root of 12, except this one, different from this one. This one we can continue, and we can take out the square root of 4. This would be 2 times the square root of 3. Here you can rationalize the denominator. That's going to be, multiplying by root 2 over root 2. That's going to be 5 root 2 over 2. We saw a few problems above where you could simplify. This one does not simplify. 5 over 2 does not simplify. If you did express this as a decimal and said 2.5 root 2, that would be fine. Okay. Obviously, you can't express it as the irrational decimal that would incorporate the square root of 2, but 2.5 root 2 is the same thing. I do like the fraction better. So does every other teacher in my department. Here you can take out a 25. So root 25 is 5. That's 5 root 3. Here you could take out 100. That would be 10 root 3. Here you could take out a 25. That would be 5 root 5. We'll come back and do this one in a few moments. Here you could rationalize the denominator. That would be 7 root 3 over 3. Here you could square root the 49. You can test into 15, but there's no perfect squares that come out of 15. No simplifying to be done in the numerator, but you can square 49 to be 7. This is root 15 all over 7. Next, 60 divided by 12 is 5. This is the square root of 5. Next, rationalize the denominator by multiplying by root 3 over root 3. Let's do that. Root 3 over root 3 would be 3 root 3 over 3. And the 3 over 3 would cancel, and you're left with just the square root of 3. Okay? How about this one? This is interesting. You learned in a power rule in chapter 8 that you could square the 2 and square the root 3. I don't mean you could, I mean you should. So that would be 2 squared root 3 squared. This is one of the power rules, power of a product. Okay? And that would then be 4 times root 3 squared, which would just be 3. This is going to be 12. Now, just the same, give myself a little more room here, you could multiply 2 root 3 by 2 root 3. In which case, I would put the 2's together, right? This is just 4 things being multiplied. So it's like saying 2 times 2 times root 3 times root 3. Here you'd get 4. Here you'd get 3. And when you multiply them, you'll still get 12. (41), when you multiply 12 and 27 and then square root that, you'll get 18. Next, very similar to number 40, so I'll just tell you the answer. It's 245. Next, very similar to number 41, so I'll just tell you the answer. It's 4 root 7. Check them if you want to. Next is very close to 40 and 42, so I'll just give you the answer, and it's 125. Here, 8 times 7 is 56. This is root 56. Think of the number that you could take out of 56. It's only 4. Okay, 4 is the biggest number that you can take out of 56, so this would be 2 root 14. If you divide 4 out of 56, you'd be left with 14. So square root of 4, square root of 14. You should take the square root of 4 then, so that's the 2. Coming back to 46. 47, I'll tell you the answer is just 20. 48, let's go ahead and do that one down here. I would move things around. So you have 4 times 2 times root 3 times root 6. Just put them next to each other so they're easy to show multiplication. This would be 8. And root 3 times root 6 is root 18. And then you could take a 9 out of root 18. That's root 9, which would leave you with root 2. And you know that root 9 is 3. 3 times 8 is 24. Oh, I made a mistake. I should have looked at my key sooner. Back up. That's not a 6. It's a 2. Beg your pardon. This would be root 6. And no simplifying could be done. It's just 8 root 6. I got almost all the way through without making a mistake. All right, back up to these 6 problems that we need to do that we circled in red. Okay, now kind of consider this the last important thing. We're square rooting 12 and we're square rooting x to the 4th. You know that x to the 4th could be square rooted, right? something that's to an even power can be taken to the second root. The square root is really the second root. So what I would have you to do here is go square root of 4, square root of 3, square root of x squared, square root of x squared. Now, is that necessary? No, but I think it's a great place to start, okay? And what can't be square rooted here is this right here. So that's going to remain, and that's going to be tacked on to the end of the part of our answer, okay? Everything else can be square rooted. This would just be x, this would just be x, and this, of course, is 2. So this is 2 times x times x. How do we express that? That would be x squared, and then the square root of 3. Our answer is 2x squared root 3. Okay? Now, contrast that with this problem, number 16. You can take the square root of 48 and break it up into the square root of 16 and the square root of 3. So that's square root of 16, square root of 3. And then you can't just take the square root of s to the third. You can take the square root of s squared, so we'll take that much of it, and that'll leave you with just the square root of s. Okay, now let me take a step back a second. I should have mentioned this. Over here, the reason that I was able to break this up the way I did is because you have two properties are being employed here. One of them is one we already talked about, which is when there's a product, you can multiply what's underneath the radical symbols. So the square root of x squared times the square root of x squared would be the square root of x to the fourth. I did that, but I just did that in reverse order. Here you have the square root of x to the fourth. I made that square root of x squared times square root of x squared. Now, you can also, the reason that you can do that is because 2 plus 2 is 4. Remember your power rule. X squared times x squared, since we're allowed to do that under radicals, would be x to the 2 plus 2. That's x to the fourth. That's why we're allowed to do that. Same thing here then. Here's s squared. Here's s to the first. We can multiply them being under different radicals. They were together. I separated them for the purposes of simplifying. And s to the 2 plus 1 is s to the third. Okay? Now, what can't be simplified? Square root of 3 can't be simplified, and square root of s to the first can't be simplified. But this is 4, and this is s. And then what's left should be just tacked onto the end, and you can put them underneath one radical. I wish there were a few more examples that I could give you, but these few will have to do. So that's, and also be careful that your s's don't look like 5s. That's an s. This is 4s root 3s. Okay, a couple more. Here, this is a lot like the first one that we did. So this is like saying root 25. You can just kind of break them up into two things. And both of these things can be square rooted, so 5x. 35, what can we take out of 28? I guess 4, right? So root 4, root 7, root x squared, root x squared. After you do a few of these like this, you'll figure out that there's a division taking place, but I don't want to give that away. So I think this is a good way to start. And anyway, here's the part that can't be simplified. Root 4 is 2, root x squared is x, root x squared is x. You have x times x. We write that as x squared, and then you have root 7. 2x squared root 7. And I guess one more. I feel like there was 6. Did I already do 5? Oh, I skipped 13. I'll come back to that too. I felt like I had missed one. All right, square root of 3x times the square root of 5x would be the square root of 15x squared. Now, is there any perfect square that comes out of 15? Nope. So here, you could square root x squared, and then what would be left would be root 15. This is x root 15. X times the square root of 15 is simplified. And then let me go back to the one that I jumped over. Here, I would multiply by root 2a over root 2a. Actually, I'm kind of glad I saved this for last because this is the rationalizing the denominator component. You have a denominator that's irrational, so multiply by that denominator over itself, and you will get in the numerator 4 root 2a, and then the denominator, root 2a times root 2a, would be just 2a. And then finally, what you ought to do is simplify the 4 over 2 and then write your answer. So I don't have a lot of space here, but it would be 2 root 2a all over just a. You see, because 4 over 2 reduced to 2 over 1. So 2 root 2a all over a. Okay, that was a lot. Again, I hope you paused it and kind of mulled over the facts if you disagreed with something or if you were confused. Now go ahead and do the book assignment that I have posted on my website. Thanks for tuning in.